Oh yeah, once again, welcome from that short break. After doing question 1, 2, and 3, now we're doing question 4, memorandum, that is 2025, paper 1, mathematics. This Patrick Kamala once again, to mathematics and physical sciences. Okay, you can teach us, we can teach you online, one, or you can come to the center. So this question here is question 4. They say here that the graph fx equals to log base a third of x is drawn below. Point A is the x-intercept of the function, and the 3:t lies on f is this point here. Then the that calculate the value of t. So this is a function here. You guys don't see it properly, but let me write it here properly. It is f of x, okay? F of x equals to log base what? Base 1 over 3, okay, of t. Now they say that 4.1, calculate the value of t. Now this point 3 is to t lies on the same function. So we see that in this particular case, if we say that our y, okay, equals to log base 1 over 3, okay, of t, and then this point lies there. So this point here, which is 3 is to t, lies on this. So we can find our t here. Now in this particular case, our 3 is the x, our t is the y. So we're looking for t, we're gonna say our t equals to log, okay, base 1 over 3 of t. We're looking for this t here. Our x is, yes, our x is the 3, yeah, beg your pardon. This must be 3 here. So this is log base a third of x here. So I'm gonna put a 3 here now, because looking for this t here. So this must be x, okay. Now when we do substitute here, our x is 3, so I'm going to put a 3 here, and so now to get our t here, now if we are solving a log equation, better put it to exponential. But what we must note is that the exponential and the log, they have the same base, né? So here our base is 1 over 3, so it's going to be 1 over 3, okay, to the power t equals to what? Equals to 3, okay, equals to 3. Or you can get it direct from a calculator, by the way. But here I can say 3 power minus 1 times t equals to 3 power 1. So because I have the same base here, my t equals negative 1, as you can see it here. So our t is negative 1. All right, so this point is what? It is 3 is to negative 1. 3 is to negative 1, okay? And then next here they say 4.2. Write down the coordinates of A. Now this A is the x-intercept. A is the x-intercept. A is the x-intercept. Now they gave us the function here. What do we know at x-intercept? That our y is 0. So using the same equation, that is we said y, all f of x equals to log base 1 over 3 of x, okay. So looking for the coordinates of A, that's x-intercept, where y must be. So I'm going to say 0 here. 0 equals to log base 1 over 3 of x. So I'm going to say here a third, again 1 over 3. Remember I said the same base, the same as exponent, and log, okay, equals to x. So what at the power 0? It is 1. So our coordinates of A, we have them as what? As 1 is to 0. Then let's say here 4.3. Determine the equation of f inverse for this function, the form y equals to what, okay. So in here now, the equation which we're dealing with here, this was 4.2, okay. Now we're dealing with this equation, which is the logarithmic here. It's inverse, okay. We want the inverse now. So our function is what? equals to log base a third of x. Now to get the inverse, you swap x and y. So we're going to say our x equals to log base a third of y. So in here, in exponential form, it's going to be actually now this one to make our subject of the formula, it must be from log to exponential. So it's going to be a third to the power x, okay, equals to y. So that's our inverse. So our inverse is y equals to a third power x, but you can also write it like it. You can say that y equals to 3 power negative 1 times x just minus x. So that's our answer here. All right, next question here. What do they say? Here that write down the equation, the asymptote of the inverse function. Now the inverse function, we want its asymptote. All right, and they say here that draw the graphs of the f inverse on the set of axes provided, and then indicate the intercept with the axis, the coordinates of one other point on the asymptotes. Okay, so mean that before I tell you the equation to the asymptote here, let me first draw for you the function here, the inverse, then it will give us the asymptote. Now, guys, note that remember we swapped x and y here, meaning that the inverse is a reflection of function in the line y equals to x. So in here, if I may put my line here, y equals to x, and try to draw the inverse, okay, I can do like this. Okay, so if this is the line y equals to x, this one here, you see in red. I'm trying to draw the inverse. After drawing it, I'm gonna get the what? I'm gonna get the asymptote. Okay. Now this line is the one which you call y equals to x. It's called y equals to x. It's called y equals to x. Okay. The line y equals to x. When you reflect the original function along this line, what you get, we call it the inverse. Okay, so this line is called y equals to x. Okay, now because it's y equals to x, now this one being 3 to negative 2, it's gonna be somewhere here. Okay, somewhere this side here, and then because this for this given function here, this one, remember that I'm putting my mirror here, right? So mean that if I'm gonna draw my inverse, okay, this coordinate a, its inverse or its image after this is gonna be somewhere on this, somewhere here. Okay, somewhere here, and then it's gonna come now something like this. Okay, don't forget here what you see here, it is the exponential function. Okay, the exponential, right? So, and if I may put in the coordinates, for example, if I say x negative 1, if I have x and then y here, if I say x is negative 1, I'm gonna say here 3 power minus 1 minus 1 is gonna give us 3, so it's gonna be passing at 3. Okay, then if I say x equals to any number, let me say negative 3. Okay, yes, if I say x equals negative 3, this was negative 1. If I say negative 2, if I say x equals negative 2, I'm gonna have a 3 power negative of negative 2, which is giving me 9. So I'm passing at 9 here. So you see that it's going up. Okay, and then if I put x equals to 0, when x is 0, it is passing at 1, because if I put 0 here, I'm gonna get to the power 0, which is gonna be at 1 here. So it's cutting here at 1. All right, so if I may sketch this now to look like this one here, so let me sketch it here like this now. They come like this. then like this, then like this. So this is my inverse. Okay, so these points here, negative one, this one here, it is 1, right? Because it is 1 here and 1 here. So negative 1 is to 3. You can say negative 1 here, then to 3, somewhere here. And then negative 2 is to 9, negative 2 somewhere here. And then to 9. So it sits up there, like this. Okay, so this is our inverse, which we have sketched here. Now in here, as you can see, the asymptote is this x-axis. So our answer here for the asymptote is what? It is 0. Because they wanted this asymptote here. It is y equals to 0. Or you can say x-axis. Now they say here, okay, we're done drawing, but it's now we must put one other point, one other point here. Now because this one is 3 is to negative 1, it becomes negative 1 is to 3, so we must put it just so they want us to show them here at least one other point here. So we have negative 1 is to 3, negative 1 is to 3. That's our other point here. Yeah, that's our function there, the inverse. So this is the inverse here, f inverse. This is the function here. All right. What else do we need now? They say question 4.6 here. They say here that the graph of h is obtained when f inverse is translated 5 units to the right. Determine the y values of h where x is what? Bigger than 4. Now to translate means to slide over, like see curve here. This one here is gonna slide by 5 units to the right. Now when we translate to the right, our function, the function is our, don't forget that our first in our f inverse, our f inverse, this one here, the inverse function, okay, we got it as what? As 3 power negative x, right? Now to get our h after sliding, okay, it's gonna be translating here. They said how many units to the right? They said the 5, let's check it here. They said 5 units, yes, 5 to the right, so it's gonna be x minus 5. So we say here minus 5. Okay, now give her 3 power negative of what? Of x minus 5. Okay, now this is our h of x. Now they said that what must we do? Determine the y values of h where x is greater than 4. Now this is 4, it's gonna be like our value, So remember here we have it at x equals to 3 here. Here our x is 3, this one here. Our x is 3 somewhere here. Then 4 should be somewhere ahead here. 4 should be somewhere ahead here. But then we have to translate this function. Let me translate it now. Do we see what happens? Okay. Now if I do translate like I said, it will slide over. So here what we do here, you can first okay, if I can do like this and I copy this, let me see, and I say paste. You see now, what I have here, function, you see here it was like this, so if I say translate, okay, it goes like this by how many? By 5 units now, 5 units, okay. So now as you can see it, although I'm translating, it is still above the x-axis. You see here, still above the x-axis, which means that now from 4, they said x bigger than 4, so let me translate one again. Let me continue here. Okay, let's say somewhere here. Okay, so now, all right, okay. Remember the negative 1 is going to be here at 3, because when you say negative 1 plus what? Plus 4, you get 3 here. So it's going to be like this now. Okay. So We're looking for the y values, né? Meaning that what we're looking for, this point now here, this point here, okay, this point here now, it's gonna be somewhere here. But we're talking about 4. 4 is somewhere here, né? So somewhere here, okay. So now we're looking for the y values, né? Now this is our h now. This is our h now after translation, né? So what I'm looking for this y values from this point here, like this. I want these ones here. We put them in green here. From this point here, okay, like this, okay. Now as you can see, I want these y values, né? Now this is my 4 here. They said x bigger than 4. Now for x bigger than 4, you see we are going this way, né? We are going this way, and it is still does not go below the what? Doesn't go below the x axis because that is the asymptotic. So I'm gonna find out when x equals to 4, what happens here. When I put x equals to 4, what's my y here in my h? So if I put x equals to 4 here, meaning my 4 is gonna be 3 or negative of 4 minus 5, okay, give 3 power negative of negative 1, which gives me positive 3. So in other words, this value here, the y corresponding to this 4 here, it is a 3. So this point is what? This point is 4 is to 3. 4 is to what? 4 is to 3. So here, my y is 0, okay? Here, my y equals to what? Y equals to 3. So I'm looking for this y value. So my answer here is going to be values, okay, between 0 and what? And less than 3. Okay. Hope we are together. That's our answer here. All right. If you're not together, please you can link us on 0785 for more explanations. Thank you.